Today here on the bench a Teletron T-8800 series, and this radio needs to get frequency converted, and that is the challenge with this radio here. Welcome to TRX Bench. Okay, so let's go right into our video. So the Teletron we have here is a German radio, and it was produced especially for business services such like fire department, police, or taxi, or buses, or whatever. So this radio here is real high quality. The problem is that all the components are used in this radio are not any longer on the market, and due to the fact that it was no consumer product, you do not really get a lot of parts, and that is the challenge, because this radio is, I don't know if we can see it here. Let me see if we can zoom it in. I believe no. So here is an ASCOM sticker as well, and it is telling us, and no, I cannot get it here on camera, but anyways, believe me, this is a T-8800, which is saying that this is a 10-meter radio, and in fact this is a very seldom radio, because as I said, it is really used as business radio, and yeah, so it is more 4 meter, 6 meter, 2 meter and 70 centimeters, where these radios were built for, and not really for 10 meters, so that is really seldom. And that is also the reason why this radio here was on a relay station for a packet radio, I believe. So TNC was connected to the radio, and so forth and so forth. And now, because it is a high quality radio, the operator of this relay just wants to use it in the future as well. Even he do not need it for a packet radio anymore, because no one is using packet radio, but it should do his job for RPRS purposes, and therefore we need to convert the frequency. So for the moment in time, so let me see, so we have here a little sticker on the radio, and you see 29, I don't know if you can see it, yeah. So channel 110 is 29 280, and you see that was used for packet, and that is what the radio was dialed in here. So you see it here at the channel switch here. So 110 is 10 meter 28 29 20 80, and that is what the radio is switched to. Now, for RPRS purposes, we need to convert our frequency to 29 250, and you see there is no frequency here available which fits, so no frequency which is programmed here into our radio is at least at 29 250. So we have a bunch of different frequencies, but no 29 250. And that is now our problem, because we need to reprogram this radio. And yeah, let me go ahead. I show you what I have, and then you might understand why that is really an issue. Okay, and that is what I have, and believe it or not, this is really the only documentation I have, and it is here from the synthesizer. So the owner just put this piece of documentation to his files, and that is because we still have it. But other than that, I have really nothing. So we only have the synthesizer board. But anyway, so that is what we really need. And we have to concentrate here on this IC, which is the S187, I believe. And we see here two ROMs, and in these two ROMs we have finally the binary code which is needed here at our S187. So that is a PLL IC, okay, and we need here the binary code. And you can see it here. So we have here our A inputs and our B inputs, and you can already see the binary value here, 1, 2, 4, 8, 16, 32, 64, and that is the binary value of this digit. And our ROMs are getting here to it output the respective binary code to program here our PLL IC to get finally our frequency out of the radio. This ROMs, or you see it is mentioned PROM here, is a type which is not any longer on the market, so you can only program it once, and then it is done, so you can't reuse it, so it is not erasable, and therefore, yeah, we really have a problem here with these PROMs. And well, we have seen here on the radio our frequency list, so all these frequencies are programmed here into our PROMs, and therefore we are able to switch these channels. Now, as we are not able to get these components any longer, so we really need to find a new solution. And I mean, we really do not need a bunch of different channels, so we really need only the one new frequency, the 29250, and therefore we do not really need this PROMs or ROMs any longer, as we only need to give the right binary code to A and B, right, for transmit and for receive. So as we have different local oscillator frequencies for both TX and RX, we need different binary codes for both. I mean, it is for the same frequency for 29250, but we need different binary codes. And first, what we need to do is to find the binary code to be able to program our PLL in a way that the radio is really putting out our 250 kilohertz on TX and RX. Okay, so far the theory for the first step. Now let's hook up the radio and let's see if it is working on our two 290, 280, right? To see if the radio is working, and then we can think about how we are able to program here our new frequencies. Okay, and there we have directly another issue. So there is no speaker jack here somewhere, and the radio itself does not have a speaker here inside our housing. So we only have here a connector, and you see here we have an old DIN Stecker connector, connected it here to this, I don't know what it really is. It is a sub D connector, I don't know. Anyways, so we only have this here, and this was connected to the TNC, and of course we have plus and minus to just supply the radio, but other than that there is nothing, so we cannot easily connect our speaker to the radio, and that makes it even more complicated to operate the radio. Okay, so let's then supply here our radio with 13.8 volt. Okay, so that is connected, and our radio communication set is connected as well. So let me supply the radio here, and I don't know if I need to switch it on, and you see we have backlight, and you see no, you can't see, it is pulling current, which is telling me that it is obviously on receive. Now I do not know how this connector is wired inside, but the owner told me that pin 3 is PTT and pin 2 is ground. So yeah, so this here should be our speaker volume, but as we do not have a speaker connected, that is a problem. Anyways, and what was our frequency? It was 2928. Okay, so I have already dialed in the right frequency to the test set, but yeah, okay. First of all, let's see if the radio does anything. And let's try if I bridge it simply. And alright, so radio is going into transmit. So radio is doing something. Let me show it to you. Interesting are the upper two displays. So left will show our transmit frequency. Now you see 2928 because this is the receiver frequency, so the generator is sending out with the same frequency as well. And on the right hand side you see for the moment in time our receiver output level. But now I'm switching over to transmit. You will see it when it goes into transmit that you see not green LEDs lit, you will see red LEDs. So let me see if I can do it here once again. Here we are. Now you see the LEDs are red. I hope you see it. I can't see it here on my screen. But you see it is 16.8 watt output, and you see that the output frequency is really looking fine. So the counter is now counting the output frequency. So radio is on 2928, so everything is fine, and it is 16.3 watt output. So the radio is really doing something, but now we need to think about how we can check for receive. Okay, and as we have here a lot of free pins here in our connector, I hope that there will be somewhere our output signal, and therefore this is an excellent job for my for my signal tracer, right? I have tested that this here is ground, and therefore now I can go and check here our pins. There is nothing. Let me see if our level is high enough. I have increased it here a little bit. So let's see if everything is fine here. We have something there, but the signal is so small I do not believe that that is really our output audio stage amplifier. So that must be something different. So let me flip over here. How can we handle it? Maybe that way here. So let's see if we can find here an audio signal. Ah, okay. Here we are. So that sounds much better. So here we, can you see it? One moment. Maybe that. Maybe you can see it this way. Here we are. So you are hearing different speaker levels because my signal tracer is in automatic mode. So it is adjusting always the level, but I can read the level here on my LED display, and yeah, so there we have a nice, we really have a nice output level. And let me pick there our output level, and then we can check it here with our communication tester. Alright, so I have connected the radio now wire here, some alligator clips, to our communication set, and we already hear in the background our test tone, which is telling us that the radio is really receiving on the frequency, and that means that our radio finally is working on our RX and transmit, and we know the radio is not in any kind faulty, so that was really important for us to start with finally completely working set here. And here the figures once again, so you see that is our receiving frequency and the level, and you see here the synod. So everything is fine, so that is already a low level, so almost minus 100 dBm, and you see the radio is still working very nice. So we really can go ahead, and we know we have a good radio. Okay, so first we take the radio apart, and we have to look here for our synthesizer PCB to be able to see what we can do regarding our new programming. Yeah, and our housing is here, as you can see, sliding off, and here we have our radio. And you may already see that this is really different to consumer electronics, so you can see that this is really business electronic, and yeah, you see that the component or PC density here is quite high, so there is really not a lot of space, and you may also see that our PCBs are stacked one over the other, and that means there is really no free space, and it will be really difficult, so far I can see it right now, to get here an additional PCB in to get our new codecs managed. But anyways, first we need to find here our little board, and I believe it is down here. So it looks like that we have 3 boards here, and I believe one of these boards must be the synthesizer board. So let me simply open it here, and let's see if I'm right. Yeah, and I've loosened here the screws, so now I can lift it up, I hope. No, obviously not. This screw is still not completely loose, but now we can take it away, and we have here the interconnection between these 3 boards here, and we can lift this interconnection like so, and like so. And now we have to lift here our board out of a radio, and yeah, we really need to be carefully, and yeah, here it is, and look here, we are definitely right. And so what has been told is true. So this is the synthesizer board, and somebody was so kind, and maybe that has been done in the factory, I don't know, but somebody was so kind and wrote AB, and here also AB. So this is our S187, so our PLL IC, and these are our both ROMs, what we have seen in the schematic already, and it is marked here, so that is quite nice, like it. So what we really have to do now, as we are not able to get new ROMs, we need to do it somewhat different. But let me see, we have date codes here on our ICs. Yeah, this here, for instance, is from 89, August 89, and we have here date codes as well. Is it 87? Calendar week 45? I don't know, 87. And our PLL, I don't know, Is it a 9? 97, yeah, it is a 9. So our PLL is from 97, calendar week 50, obviously. So, and yeah, of course, so that is the reason why we are not able here to get any new. Okay, and as we discussed earlier, so our ROMs has to deliver a binary code to our PLL, and that means it is a combination of zeros and ones on this side, and of course the same here of this side, and this combinations here of 0 and 1s is finally programming here our PLL chip for getting the right transmitter frequencies out, or getting the right frequencies, most likely, not most likely, it is the LO frequencies which needs to be adapted to receive and to transmit. And I found here a nice documentation about our S187, and yeah, it is a MOS component, so that is here why I'm wearing here my ESD wristband. And I believe it is really very sensitive, so we really need to be careful that we not kill here our components by an ESD discharge. So yeah, we have to be very carefully. And we see that can you see it? I don't know. So here we can use a diode matrix to finally preset here our dividers, and then the PLL can finally give out a tuning voltage to our VCO, which is of course here, and the VCO gets feedback here into our PLL S187 component, and we have here our phase comparison, where we compare our VCO frequency with an oscillator frequency, and of course with the different presettings on the dividers, we will be able to finally give here to the VCO a different tuning voltage to get the different frequencies. So that is what is all about. And additional to that, we have here a formula which is telling us how to program finally our PLL chip. And here you see, yeah, it is a table, and is telling us how to set the zeros and ones to be able to get really the right frequency out of it. And now we need to use this frequency, and I have to do some telephone calls because I do not really know on which frequencies here our radio is finally running. So I do not know the local oscillator frequencies. I do not know how it was designed. So I need to contact some colleagues who may have a little bit more informations about this radio type, to get finally our binary code which we need to program here our S187. Alright, and after some discussions and phone calls and calculations and what have we got finally the decimal values, and that is for TXA. So remember, we have here our A portion, our B portion, which is also here at our PLA, A portion and B portion. And we have for our transmit 29250, we have 25. So, and just a moment, you will understand what I'm talking about in a bit. For B, we have 58, and for receive, we have A15, and we have B101. And once again, this is decimal, and we need binary. So we have to convert these values into the binary code, as here our PLL is only understanding zeros and ones. So that is the reason why we need to convert it, all right? And that means give us some zeros and ones. And I will demonstrate it how it works out, that you have an idea what I'm talking about here. Well, we will not be able to do here a complete electronic digital course in this video, so that would be really too much. But for all of you who has already worked with codes, and in our particular case with the binary code, you know that we all know that 25 is 25, so the value is quite clear. But if you need to write down 25 only with zeros and ones, then that is a little bit more complicated. But we need to convert it, because otherwise we are not able to address here our PLL. Okay? So therefore, we are working with another model. So if we have different zeros and ones, depending on which digit we have it, we say that the 0 or the 1 has a different value. So, for instance, our first is 1, and then we go up always with a double value. 1, 2, 4. So the double of 2 is 4, the double of 4 is 8, the double of 8 is 16, and so forth. Okay? And when we now have to convert our 25, so what we can say is 25 is smaller, or smaller than 32, and it is of course smaller than 64, and that easily and you easily can see that this both digits must be 0 in our binary translation. Okay, so that is obvious. And now you see 25 is bigger than 16, so that obviously mean we need here a 1. All right, and that means still we have here a rest, and that is simply 25 minus 16 is 9. So we have still here a rest of 9. Okay, and that means 9 is greater than 8, and that means, okay, this must be a 1. All right, and now 16 and 8 is already 24. That means there is only 1 left, and that means if there is only 1 left, our 4 must be a 0, our 2 must be a 0, and our 1 must be a 1. Okay, and then you may already see that 16 plus 8 plus 1 is 25. And that is simply how you can convert a decimal figure into a binary figure. And it is easily done this way, that you look for zeros and ones, and then you simply start to add your ones all together, and you see that 16 plus 8 plus 1, because that are here our digits where we have a 1, is together 25, and all the others are 0. So that means that makes no difference to our PLL, right? That means really that only where we have a 1 are the one which makes a change. And that is how I do it now, exactly on the same way with 58, and then of course for RX with 15 and B with 101. Okay, and I have really done it here in exactly the same way as we have done it here. And if you like, so we can do it once again for all of us. So 64, 32, 16, 8, 4, 2, and 1. And as we have here 58, we want to calculate it if we, so we have no 64, but we have a 1 at 32, so 32 plus 16, because 16 is 1, and plus 8, because 8 is 1, and we have no 4, and we have plus 2, because this is a 1 and the 1 is a 0, and that all together, so that means 32, 16, 8 and 2 is altogether 58, and that is how it works out. And we have here exactly the same, so we can transfer it into the binary code. And okay, so finally that means we need here at A and B, we need this digital values, so this combination of 0 and 1s. And when we have now again here a look into our schematic, so we may recognize already that we simply do not need here our old ROMs any longer. So we simply forget about our ROMs. What we need is, of course, here our PLL, and we need here our pull-up resistors, and you see here both on A and B, you see here our pull-up resistors, which are connected to 10 volt, and as long there is nothing here connected to our inputs, you may see that then with 10 volt here connected to our resistors, okay, we have all inputs set to 1, which means set to high. And only if we pull down here a line, so if we go now here back to our calculation, so for instance, if we put now a 0 or better said, a 0 here on our second place, which has a value of 2. So you see here, by the way, also the values. Can you see that, or is that too small? So let me zoom in. You see here now the values once again. So this is 1, this is 2, this is 4, this is 8, 16, 32, 64. That is exactly what we have. Now I have to go. That is exactly the same what we have here written on our piece of paper. And if we go now and put here on our value 2, which is here our second input, we put here 0 to this point. Alright? That means we are pulling this here to 0. Alright? So that means really we are connecting this point to ground. I hope you can follow once again. So without anything connected here to this matrix, we always will have here a 1. But if a 0, if we put a 0 here to A2, which means we connect here this point to ground, because ground is in our case 0. In this case, then we really pull our 10 volt down to 0, because the voltage is now really falling here at the resistor, and this point is connected to 0, and that means we have really a 0 at our A2. And that is what we finally need to do. We really need to bring these values here to our matrix here, and then we have programmed our PLL to this code here, and then it will deliver our needed frequencies. I hope you was able to follow. This was only a side step, just to bring back to your mind that or how it works out. So what I'm doing now is I will copy this here, and I will finally eliminate here this ROMs. That means here in our circuit, our ROMs here has to go, and as well the socket where they are sitting in, so that has to go. We need to add here a little circuit that we are able to exactly get this code here to our PLL. By the way, this here is our A resistor matrix, and this is our B resistor matrix. So this component and this component is exactly what we find here. So this is our resistor matrix, what we can see here. And this is of course what we still need, but we need to get this both off. Okay, and I did a little planning here, so a little paperwork to get finally a circuit which is able to deliver what we need, and that is what should be replace our ROMs. Okay, And I have done nothing else than what I've already told you. So of course we are using here our PLL S187. We're still using here our resistor network. But then we need to add here, I have called it TX bus and RX bus. So if you like, this here is our TX bus and this is our RX bus. And we now need to exactly pull here our inputs to 0 where we need it, and you can easily see it here. So for TX we really need to get this A2 input and the A4 input to 0, and we need as well to get our A32 and our A64 to 0. So that is TX, that is A segment, right? And that is exactly the same. If we compare it here, it is exactly the same what I have here. And you see here addition, I have marked this here with LSB and this is marked here with MSB, which stands for most significant bit, and this here is the low significant bit, right? And that is what we need to add here to our combination as well. So here on our paper we have to say this is LSB and this is MSB, most significant bit, because this here counts 64 in our decimal mind, right? So this is then of course the most significant bit, and this only counts 1, and 1 is of course our lowest one. And you now see that it is now here a little bit opposite side around. So this is here our input LSB, right? And here on the right hand side is our MSB, and it is completely different to how we converted it, because there we have here on the right hand side, and that is given by agreement. So we always say that here our right hand side is the LSB and the left hand side is always our MSB when we convert it. And therefore, if we go now down here to our bus, and once again we have now to read it completely in the different way, and you see now here 1 0 0 1 1 0 0. Okay, and you already see what I've told you before. When we do not pull here the input to ground, because this is really nothing different what I've told you before. So this bus here gets low value, so 0, when TX is switched, right? And if we go over here to this transistor, so we do not talk right now here over the rest of the circuit, is only this transistor. And you see, when we are transmitting, this transistor here gets engaged, so it will switch through, and you see that then on the bus we have ground, and ground is 0, and therefore we pull this input to 0, we pull this input to 0, and where we need a 1, so a high level, so you see these inputs are not connected to our 0 bus, all right? And you can see it here as well. okay? But you have here a diode in between, because now we need this 0 here for both, for TX and RX, and therefore we need here this diode matrix. Now we pull here our input A32 to ground over this diode, and of course we have here a second diode. So this is that we do not get here a confusion into our logic. But finally, it is exactly the same. We are pulling over our diode, the A32, to ground, and we do it here with the A64 as well. We pull it to ground, and you see it here. We need the 64 value, the MSB, to ground, and the 32 also to ground. So that means I have here now done it exactly in this manner. If we are now delivering here this code to our PLL chip, different of course to TX and RX, we are able to program our PLL chip exactly in the way we need it to get at least, what was our frequency, 29.250 megahertz. So that is the way we need to do our little circuit, and this is already given in our radio. So we need to do a circuit which has this both low TX and RX buses. Alright, the upper one here, as I've done it, is TX and this is RX, and of course this here is our switching. Okay, so when I pull this point here to ground, which is finally switched over the PTT, I can change here our code between TX and RX over this little transistor network. So that is the whole story. It is basically very simple, nothing special, and that is the way we are able, in theory, to get our needed code to our PLL IC. And that is what we want to do right now. So we need to build a little circuit which is exactly doing basically what we can see here on our lower end of our piece of paper, because this is already given in our circuit. The next what I have done is based on this circuit here. Of course, I have done a proto board planning for our proto board, and this here is the planning for our proto board. And what you can see is that I have here the transistors and the resistors, and here is our diode matrix, and this here gets finally connected to our already given circuit, so that goes finally here to this lines. So that is what we have finally indicated here. So this is a complete proto board, and this is how it needs to get built finally. And you see I've here chosen some diodes. So diodes are BAT85 because they have a low drop voltage, and you see I've here simple transistors. The PMP type is the BC556, and the MPN types are the BC550. So not very special, only universal types, and now we go and build our little circuit. And yeah, that will be the next step. Let's build our little circuit on a proto board. Okay, and our little circuit here is almost done. So you see that I really tried to get it as small as possible. We have seen how really small space we only have in our unit. So I already tried here to lay down here our transistors just a little bit to be able to get it somehow into our circuit. And yeah, worst case will be that we have to do it with SMD components. But first, let's try if this will work here. And yeah, what we have here is what we have already discussed on our schematic. So that here is our TX RX switch, and this here is our little inverter to use our signal from the PTT. And then easily here we have our two, yeah, let me call it TX and RX buses. So that is what you can see here. And yeah, additional to that, I have now here to fit some of this flex wire to our circuit, and then we try to get it somehow into our circuit. Okay, so let's go ahead. And as already discussed, I have finalized here our proto board as much as possible. So you see I have added here our bus, which we need to connect, of course, to our little PCB. And now let's see if we have a chance to get this board here onto our PCB, because as we have discussed it before, we really do not have much space here. And you see the components here in the radio are already hitting here the next, can you see it? So the components here are really hitting already the next level here. So from our sandwich building here. And therefore I'm really a little bit concerned if we are really able to get it. Remember, so this PCB has to go in that way, and the highest component here on the PCB is here our little crystal, and our complete board is not allowed to be in any way higher than our crystal here. If it is only a bit higher, then we already are really in trouble, and that is what I really need to figure out, if we can get it managed here somehow. Now we are approaching the point of no return, because now I have to take out here our IC sockets, and then yeah, we are really at a point where we have to go forward. But anyways, that is what we want, so nothing wrong with it. Okay, so first let me unsolder here our IC sockets, and then let's see how we can get here our little PCB on our board. Okay, so let's start and see that we can go ahead. Okay, but finally this is boring, so let me finalize it, and then we show how we go ahead. Okay, so everything is prepared so far. So you see our sockets are out, and here my little wires are tinned. So now I can connect them here to the right place where they have to go according to our schematic. Additional to that, I mean, I hope that I can place it all like this here, so that I can put this little board here over the PLL IC, and I think, but we will see when we really have to put it into back into the radio. So I think we are really was able. We really was able here to bring it in the right position here. Hope you can see it. So I hope that it will fit, but finally we will see it when we put it into the radio. So I guess it is a good idea to put here some Kapton tape over these areas just to avoid shorts, and I think I have to put Kapton tape as well here over our little board, because if we put it like this, then this here will face down in our radio, and that means that you know, this will somewhat laying here on the ground, and therefore we really need to make sure that yeah, there will no shorts possible. So that is our most important point where we need to take care on. But first, now let me install our board here to the PCB, and then let's see how it works out. Alright, so we are making progress. So you see our board is in, so it is soldered, and now we really need to isolate it here a little bit as well with Kapton, as I have to put it here somewhat this way here. Alright, and to be sure that really nothing goes wrong, yeah, I better do some Kapton over here as well, and then we can go ahead. Okay, and everything is covered here with Kapton tape. So we need to get our wires out here on the left side, and yeah, have a look. So that is really unbelievable. So it really fits. Yeah, it is just working out good. I mean, it could be a little bit more space, but it looks like that it really fits here into the board. So we need this wire still, but other than that, it is really not easy here. But as you can see, it seems to work out. So let me go ahead, let's try to fix the board here on the chassis. I really would wish we had a little bit more space, but I mean, you see how narrowed down this hole is here, so that is really it is incredible. Okay, so let's go ahead. And finally our board is in, and the only thing we can see here, so this is our PTT line to switch TX-RX. Other than that, you see it is really in, but believe me, it only 1 millimeter more, and it wouldn't have been worked out that way. So that was really tough, believe me. But anyways, now it is in, and well, we are about to test. Okay, and for testing purposes, I have installed here our front panel. Of course, we need it. Everything else is just fine, and connections are done so far. Now let me adjust here a little bit our power supply, because you know we really need to be careful, and we crank it all very slowly up. So let me go here down to 0, and of course let me go down to, yeah, let me say 500 milliamps, because we know that the receiver was working with 400 something, I believe. And then of course let me switch here my speaker to not to dummy, but to speaker. So that is what I've done. Now remember, we was planning for TX and RX 292050, right? And that is what I've dialed in on my communication tester, and you can see it here. So our radio communication tester is set to 29250. We are sending with -100 dBm, and we have set our test set here to 3 kilohertz deviation. So that is all prepared, and now we can slowly crank up our voltage. Okay, so you can see the radio, you can see our power supply. Of course I switch it on here, so that is what I've done. And now I'm going to increase our output voltage, and oh, I have to switch it on, of course. Now the power supply is switched on, and yeah, I'm observing, of course, the drawing current, because we need to minimize the risk to kill here something in the radio. Now it is starting to draw current, obviously. And that was stupid, because it wouldn't work if our plus is not connected to the power supply. So once again I'm again back to 0, and let me start once again cranking up here our power supply, and you see it is starting, and yeah, light is already on, I believe, looks like, but yeah, we are only on 6 volt. That might be too less. Let me show that we still have both. So let me go up. Whoa! Whoa! 8 volt. And let me go up to 13 volt, which we have. Let me switch out the speaker. Let me go to dummy. Alright, so radio is running. So we have 13 volt 416 milliamps, which is good. And you hear the tone, and now no fake. So let me go up, that you directly can see here our test set. And once again, there's a little reflection, so let me see if I can do it any better. And yeah, so what we can see is the radio is receiving on 29 to 50. So that means our conversion board seems to work minimum for RX. Alright, so you see we are receiving with 33 34 dB SINAT, which is not bad, with -100. Everything is just fine. So our logic seems to work with our little board. Right, now of course we need to try out if transmit is working as well, and therefore we have to set the radio into transmit. Okay, so what I have to do first is, yeah, let me switch the radio off. So what I need to do first is, okay, for transmit we need, I think we was approximately a little bit below 5 amps, so that means let me simply here increase my my power supply to 5 amps output power, right? So that is what I've done. Now I switch it back on, and of course now I'm switching back on the radio, and you hear radio is receiving. I told you that this here is our PTT line. I mean, it is not really PTT. It is connected, or it will get connected with our PTT contact in the radio. This is only to switch our little logic board from RX to TX, and we need to check first that function. That is very easy because we know that it will switched by simply putting it to ground. And okay, so that looks good for the moment in time. It is switching. Okay, we do not know if it is working right, but anyways, the next is we need of course to do here our connections on the real PTT pin. So as I said, this is our first step. Now our PLL board, our synthesizer is already adjusted to TX29250. I hope you hear that receive is gone, and when I take it here away, it is back. So that tells me it seems to be okay, but we still don't know if the conversion works quite fine, and we don't know if we really have transmit. So let me prepare it here this way. and we know, so that is now ground. I've connected ground, and now if I connect PTT and PTT's left pin, our first pin here on the left hand side, and let's see. Wow, that looks good, and I show you in a second the test set. So look here to this arrow. So on receive, this is telling us it is a receiving signal, and when I connect it here now to transmit, okay, and I connect here my PTT, then you see we have now an arrow which is telling us it is an outgoing signal. The power supply is drawing 4 amps, and I have output power, and I show it to you directly. I just do it the same way. I do not interrupt the video, so sorry for that. It is not a very good video work here, but let's do it this way. So we see it is still in receive, and now you need to watch our upper left display. So that is telling us the TX frequency, and the right upper display is telling us the output power, and both is of course important. We want to have output power, and we want to have our TX frequency on the same as we have it here on RX. So 29, 20, 50 will be our output frequency for TX if our conversion board works right. Okay, so let me do it once again, and here it is, and we have 29, 24, 998, so very close. So that is great, and we have 15.5 watt output power, so that is working perfect. So now back to receive, and you see we have our sign back, and you see the nice clean sign on the scope, and yeah, you see everything is working just fine. Yeah, and what can I say? I really would call this a successful project. So our little conversion board, what we fit here in onto our PLL board is working, and we have here our ROMs, which we have taken out, and instead of our ROMs we have now our little conversion board. You know that story. What I have to do at last step is to connect this wire finally here to pin 3, I believe it is pin 3. Let me have a look. Yes, PTT is pin 3, which is here the left side, so I have to connect it here to this pin. I guess I have to take here the power amplifier away, that I get access here to our back panel connector. So that is the last step I have to do, but to be honest, that is now really boring, so that is nothing exciting anymore. I think we should not extend the video much more, because I do not know how much is it in time altogether, but I guess it is already a very long video. Well, so that has shown that even with old radios you are able to convert a radio to different frequency, even if you are not able to program the ROMs new. So you really can do it as we have seen it here. So you never should give up if you really have a nice radio like this, because we have talked in the beginning about that subject. So this is definitely not a consumer product. This is really business electronic. So that is B2B electronic. It is really a huge difference because it was built on a completely different level, and therefore it really makes sense to put all the effort into this radio, having it back in service on the new frequencies which we were not able to dial in with our ROMs. Now it is done, and the radio can taken back into the relay station for RPRS purposes. And well, I hope you enjoyed it a little bit, and maybe you have learned a little bit. So I stop the video here, so I do the last wire here for my own. We have seen and we have proven that it worked. So thanks for watching, and catch you next time. Bye.